Hello, geometers. This is Miss Backfish, and today we are getting into geometric proofs. Now, where we're coming to from this is we've just done some algebraic proofs, so we have a little bit of an idea of what proofs are all about. And now we're getting into those that are about geometric things, segments, angles, parallel lines, triangles. That's what geometric proofs are about, is proving some of the properties or theorems, or just it could be anything random that we want to prove about those items. So first thing I want to do with you is go over some of the things that we're going to use as our reasons, our justification for different things. Some of these have to do with what we talked about for algebraic proofs, and then some of them are different. Many of them are things we've looked at so far in our study of geometry. And then what we're going to do after that is we're going to just start looking at some proofs and doing them together. The first thing I want to say to you, though, before we do any of this, if proofs make you uncomfortable, that's okay. Okay? If you start out with proofs feeling uncomfortable, that's normal. Proofs are something different that we haven't really done before. You haven't had a lot of experience with this before. And proofs are, they're just a very different thing that at first seem weird to a lot of students, probably most students. And it can seem very difficult to understand, how am I supposed to set this up, or what am I supposed to say, or how do I know what to say? And so I just want to reassure you that first off, if you're uncomfortable with these, that doesn't mean there's anything wrong with you. That means you're starting out proofs and you're new at this. The other thing I want to reassure you is that, or to kind of just tell you, is one of the things that makes you more comfortable with proofs is just doing more proofs. There's not something like, there are things in math that there's always a certain way to do it. Like if you wanted to know, how do I graph a line if I have an equation in slope-intercept form, there is a specific way I can tell you, here's what you do with the slope, here's what you do with the y-intercept, here's what you do. Every proof is different though. So there's not really a, here's how you do proofs. There's not a way I can tell you, okay, this is, if you always do this, you'll always get the right answer. It's much more of a process of figuring out what's happening and what do I do on this step. But the more proofs you do, the more comfortable you will get with that, and the more you'll be like, wait a minute, I remember this happened on another proof, and we said it was the definition of congruent segments, and those will start to be your correct answers. So just sit back, enjoy. We're just going to do some proofs together. Recognize that this is a process. You're probably not going to feel like you're a master at it at first, and that's okay. Okay, so let's talk about these properties or reasons we're going to use. The reflexive property, symmetric property, and transitive property we talked about already with respect to equality. Now you notice this says of congruence. Reflexive, symmetric, and transitive, all three of those are sort of special in that they work for equals and they work for congruent too. They work both times. They work when we're talking about things being congruent, and they work when we talk about things being equal. Okay, so reflexive property is just saying anything is congruent to itself. So it says A is congruent to A. All right, symmetric is when you have kind of like an equation, but it's called a congruence or a congruent statement. You have one thing is congruent to something else, and then you flip-flop what's on which side. So these two, almost like equations, it's if the symmetric property of equality is for equations, and it's just trading what's on two sides of the equals. Here it's just trading what's on either side of the congruent symbol. Transitive property of congruence says I have two different things, in this case A and C, that are congruent to the same thing. They're both congruent to B. C is congruent to B, A is congruent to B, and we can say, oh, well, then they must be congruent to each other. All right, now moving down here, segment addition postulate we have done together. That's where we say basically part plus part equals whole for segment lengths. And the same idea with the angle addition postulate. We have done that together, where we said part plus part equals whole for two smaller angles that make up a bigger angle. Okay, so segment addition postulate is situations like this, where I say these two parts add up to the whole thing. An angle addition postulate is situations like this where I have two smaller angles that make up the whole big angle. Definition of segment congruence and definition of angle congruence. It depends on your teacher. Some teachers are more interested in being picky about this, some are less so. I'm fine with people saying definition of congruence for either one, but definition of segment congruence is if we're talking about segments. Definition of angle congruence, we're talking about angles. So it's not really hard to figure out which one you would use. You just look at which one thing you're talking about. Okay, and here's what definition of congruence says. And it's a very, very commonly used step. If I say these two segments have the same length, if that's a step in my proof, maybe it's step 3, and it came from step 2, and we have these other reasons, and it doesn't matter why we know that one. But if I have that step, and then I say, well, I want to change that to say congruence instead of equality. So step 4, I'm going to say that means these segments are congruent. That's the definition of congruent segments. And I'm fine with just saying definition of congruence, because that's what congruence means. It means having the same measure or the same length for segments. Definition of congruence works both ways, or definition of congruent segments works both ways. If I go from here to here, that's definition of congruent segment. If I said this one first and then use that to say, oh, okay, that means their lengths must be equal, also definition of congruent segments. So definition of congruence is always going back and forth between saying two things are congruent and saying their measures are equal. And it's just going back and forth between the two. With angles, it might look like something like this. One step says the angles are congruent, and then the next step says that means their measures are equal. That's just what it means to be congruent. That's what congruence means. So that's why it's the definition of congruence. I would say for this, I could say the definition of angle congruence or definition of congruent angles. But I'm usually okay with just saying definition of congruence. If your teacher is not okay with that, do not tell them I said that though. You go with what they want you to do. And of course, these can be 2 steps in a proof, or it can be where we just say it as one statement. Like I could say, if angle A is congruent to angle Q, then measure of angle A equals measure of angle Q. And my reason for being able to say that, for going from here to here, is the definition of angle congruence. Okay, so anytime we go back and forth between saying these things are congruent to saying their measurements are equal, that's definition of congruence or definition of angle congruence or segment congruence, depending on which you are looking at, angles or segments. Definition of a segment bisector. If you're told that a segment is bisected or bisects another segment, you're saying that it divides the segment into 2 congruent halves. So if I had this and you told me that this little line here was a segment bisector, my answer to that would be, oh, okay, according to the definition of segment bisector, that tells me that these are congruent. Same thing for a midpoint, really. If you tell me I have a midpoint, the next thing I'm going to do is I'm going to say, oh, that means these 2 sides are congruent. All right, and definition of angle bisector, same idea down here. If I'm told that I have an angle bisector, then I'm going to say, well, that means it divides it into 2 congruent smaller angles. Now, let me point out to you, in general, if you see a geometry term, a vocab word, so to speak, a geometry term like bisector or segment bisector, midpoint, angle bisector. Other examples would be complementary, supplementary. If you see a geometry word used, very often that means next thing we're going to use is the definition of that word. And what we're going to do is we're going to use the definition to say what it means. So for instance, the difference between saying this bisects and saying, oh, that means that these 2 parts are congruent. Some of this, folks, keep in mind, it's going to make more sense in context as we go. So don't be stressed out if it doesn't make as much sense to you right now. Let's go ahead and look at that context. Let's look at a proof. Here we have a proof that says O is the midpoint of NW. First clue, the word midpoint. Remember, I just said if we have a geometry word, very often we're going to use the definition of that word. So keep that in mind. But before we go any further with this, let's just talk real quick about the structure. At the beginning of a proof, I always have the given information, and I have what I'm being asked to prove. The given information is usually stated right at the top of the proof. It can be stated in, you notice there's two pieces of given information. That's what this colon is like. Here's one piece of given information, and then here's the next. It can be put into two separate steps. It could be spread out. You could say, if I have two things that are given, I could say one of them, and then say something about what that means, and then go back and say the other one. But a lot of times it's back to back at the beginning of the proof. It could also be dumped all in the same step. Sometimes that happens, where you could put all of your given information in step one and just say that's given. Regardless, proofs are generally going to start with given information, and your reason for your knowing that, the reason I know that O is the midpoint of NW, is that that was given to me. I was told that. The reason I know that NO is congruent to OW. This is actually not, you got to notice this, and I don't know that I did at first. This is not given information. This is not the same as that. So this is not given information. So I'm not going to write given right here. Notice that they said given for step 3. So since we've already used that part of the given information, this must go here. Okay, so now I have to figure out for step 2 for the reason, where did they get this? So I'm going to go to the picture. I was told that O was the midpoint of NW. And then the next step says that NO, this side over here, is congruent to this side. Well, I know that. Remember what we said we were going to use? I know that because that's what it means for O to be the midpoint. That's what midpoint means. That's definition of midpoint. Okay, the definition of midpoint is if you have a midpoint, it divides the segment into two congruent smaller pieces. So that's what we did. We found out we had a midpoint and we said, oh, then these two pieces must be congruent. And that's pretty much what you will almost always do when you're told you have a midpoint. Is very soon thereafter, maybe the next step, maybe a couple steps later, but usually the next step, you'll say, oh, that means this piece and this piece must be congruent. All right, we are ready to get to the end here. There's a word that you will never, ever, 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 ever see right here, but people always want to put right here. Don't ever use the word prove. The word prove is not a reason. Okay? That doesn't tell me why. If I said, oh, these two segments are congruent, and you said, how do you know? And I said, prove. That makes no sense. Okay? If I said these two segments are congruent, and you said, how do you know? And I said, well, that was given to me. Somebody told me that they were. Okay, that makes sense. So we use the word given. We don't ever use the word prove as a reason because it's not a reason. So I have to figure out on my own how we know these are congruent. Well, OC is mentioned right here. And OW is mentioned right here. And in these two steps, we see that both of them are congruent to NO. Here it says OW is congruent to NO, and here OC is congruent to NO. Well, one of our properties says if two things are both congruent to the same thing, they're congruent to each other, and that is the transitive property. So we're going to use the transitive property of congruence here. I am fine with you just writing transitive property. The reason we would know it's of congruence is because we're talking about congruence. If that was an equal symbol, this might look differently too, but if that was an equal symbol, it'd be the transitive property of equality. All right, let's try another one. This one's a little bit longer. First thing I want you to do is I want you to look, and we get in the habit of doing this, look at the start of the proof for the given information. There's only one thing that's given here. It's that statement right there. So I'm going to go looking for it in my proof. Segment EF is congruent to segment GH. There it is. Okay, so my reason for that statement is given. So I've used all my given information. Okay, another thing I could fill in here if it wasn't already filled in for me is that whatever I'm being asked to prove has to be my last statement. Because this is the finish line. This is what I'm being told. This is the finish line. As soon as you can say this, then you can stop. So we have to be able to say that last. Do not write the word prove over here. That's not a reason for knowing that. The reason for knowing that has to do with what happens in here. All right, so let's go back to where we were. We were given that EF is congruent to GH. I'm going to go mark that on my picture. Okay, we were given that those are congruent. The next thing says almost the same thing. The difference is instead of saying congruent, it says their measures are equal. Remember what we said about definition of congruent segments? That's what's being used there. Anytime you go from saying two things are congruent to saying that means their measures are equal, that's definition of congruence. In this case, it's definition of segment congruence. If you just said definition of congruence, I would be fine with it. All right, next, let's look at what happens between step 2 and step 3. Well, here's EF. It's still there. GH is still here. So EF is still on the left side of the equal sign. GH is still on the right-hand side of the equal sign. The only difference is now I have this extra plus FG. And it's on both sides. So what that means is it's been added to both sides of the equation. Okay? It's added to both sides of the equation. That's one of my properties of equality. Do whatever you want as long as you do it to both sides. That's the addition property of equality. Let me point out to you that this step right here is why we had to rewrite the congruent statement as equal measures. Because we make objects are congruent, okay? Their measurements can be equal. When we add, subtract, when we do mathematical things, we do them to numbers. We add numbers. We don't add items. So I wouldn't say I'm going to add these two segments. What I can say is I'm going to add their lengths. That's what that means. Remember, if you have a segment name and nothing on the top, that means the length of EF is equal to the length of GH. And this means I'm adding lengths. So that's why we had to change it to be talking about numbers, is because we were about to add something. Now let's look at step 4 and analyze where that might have come from. Okay, it says EF plus FG equals EG. Let's go up here and look at what we're talking about. EF plus FG equals EG. That's part plus part equals the whole thing. That's the segment addition postulate. But I'm going to go ahead and check and make sure this is as well, since I'm writing them both on the same line. GH, this part right here, plus FG, this part here, equals FH, equals the whole thing. That's true. This part plus this part equals FH. So that's the segment addition postulate. Okay. Now, EG equals FH. All right, we got to figure out where that comes from. Well, EG is right here. That's the first time EG was mentioned. And we're told that it equals this plus this. If I look up above there, that's the same thing that it said right there. EF plus FG, EF plus FG. This is the first place FH is mentioned. And it says that's GH plus FG. If I look elsewhere, I'm going to find GH plus FG right there. This says the same thing that this does. So what we just learned is that EG is the same as this, and FH is the same as this. So basically, we're putting them in place of those things. Here's what happened. It's like we had EF plus FG equals GH plus FG. It's like something has happened to this step 3. It's like I said, oh, I know something that's equal to EF plus FG. EG is. And then I said, oh, I know something that's equal to this side over here. I know there's something that's equal to GH plus FG. FH is. So I plugged something else in place of two different things. Plugging something else in place of something is substituting. That's substitution property. So substitution property. And the very last thing looks exactly like 5. Looks like I'm not saying anything different, except it looks a little different. Instead of saying the lengths are equal, this says the segments are congruent. Anytime you're going back and forth from equal to congruent and everything else is the same, you're saying that about the same things. That's definition of congruent segments. Or of segment congruence, you could say it either way. I'm going to use the symbol for congruence. So there is my proof. Okay, looking at this next group of proofs, I'm going to draw a line. Okay. Looking at this one right here that's numbered number 1. It has an item bank. You get to choose from these reasons for A, B, and C. So I want you to pause the video and I want you to think about what belongs where and see if you can fill in these reasons, A, B, or C. You can write them out or you could use those letters if you want to. After you do that, go ahead and do the same thing with number 2. Number 2 also gives you reasons, and you get to decide which one of those goes where here. So hit pause, try those. Okay, did you hit pause and try them? Because you need to have already done that before you watch me do them. Okay, so I'm going to do them now. This one says, given RV bisects, that's a geometry term. I'm probably going to use definition of bisect or definition of angle bisector. And there it is. Okay, it bisects angle SRT. That means it cuts it into 2 equal pieces. All right, and so that's what, remember, definition of something is what it means. So that's what that means. We're going to use that. And angle 3 is congruent to angle 1. So both of these pieces of given information, notice, are dumped into step 1. So I'm going to say C for given. Step 2 is saying that angle 1 and angle 2 are congruent. Well, that's what it means for RV to bisect this bigger angle. Because bisect means cuts it into 2 congruent parts. And we already said we're going to use the definition of bisect, which means to cut it into 2 congruent parts. So that's what that's from. That's how I know that angle 1 and angle 2 are congruent, is because I was told that this is bisecting the larger angle. Okay, SRT, I'm going to trace that to make it clear where we are. Okay, now, last thing here. How do I know, based on this information, that angle 3 is congruent to angle 2? Well, there's only one thing left here, and that's transitive property, but let's look at how that would apply. Here, I know that angle 3 is congruent to angle 1. Here, I know that angle 2 is congruent to angle 1. So we have 2 different angles that are both congruent to angle 1. When 2 things are congruent to the same thing, they're congruent to each other. So that is B. All right, let's go ahead and look at proof 2 here. If you have not already, please do that before you watch me do it. You want to give yourself a chance to see what you can figure out. All right, notice that I have 2 pieces of given information here. This is 1, this is 2, and they are not all in step 1. Segment BD has the same length as segment AD. The length of BD is equal to the length of AD. That's here. That's given. I'm going to say B. This says the length of AD plus the length of DC equals the length of AC. Boom. Given right there. And then I have to figure out how do I put those things together to get this. Well, I have a hint over here, but it's substitution, and here's the substitution. Look at this equation right here. I'm going to actually write it. The equation from step 2 says AD plus DC equals AC. But then look at step 1, and in step 1, we know that BD is the same thing as AD. Now we have what it says for C for step 3. That's substitution. I just put BD in place of AD. I substituted it, and that's why A is going to be my answer. Okay, so the next few proofs we look at here, it says choose the reasons from the following list for each proof. So all of the proofs below, these are your reasons. These are your possible reasons for the next few proofs I'm going to show you. All right, so here is proof 3. Proof 4. Proof 5. And proof 6. So here's number 3, 4, 5, 6. And for all of those, the reasons you're allowed to use come from this list right here. Okay, it's either it's either substitution property, given, definition of midpoint, definition of bisector, or transitive property. And I'm going to check that real quick because I feel like I remember from the past that there was one more that's left off of that. So let me check that for you. Okay, I'm glad I trusted my gut. These are your reasons you're going to use on this page. And here's the one they left off. There's a lot of different things you can say for steps where all you're doing is simplifying. You could say combine like terms, or you could just say simplify. Remember that that's only if you're only putting things together on one side of the equal sign. If you do anything to both sides of the equal sign, that would be a property of equality. It's more like if you just happen to have 3 plus 5 over here and you put it together and call it 8. Simplifying. So one step on one of these proofs, you will have to use the word simplify, and that's fine. Okay, so I want you to go ahead and try these. I'm also attaching them to your Google Classroom, so if you want to look at them on a better screen as opposed to on the video, go ahead and try all of these and see if you can get the answers correct. Make sure you hit pause because I'm about to go ahead and go over them. Okay, hopefully you've tried number 3 now because I'm about to go over it. Number 3, AH is the bisector of angle GAI. Well, that's right up there in the given information. Angle 1 is congruent to angle 3, also right up there in the given information, so I'm going to say given. Then angle 1 is congruent to angle 2. Well, how do I know that? Well, they just told me that AH was the bisector of GAI, so I have to look at the picture to see what that means. AH bisects this angle. That means it cuts it into 2 congruent pieces. So that's what bisect means. It tells me the fact that if they told me it bisects means that angle 1 and angle 2 have to be congruent. So that's the definition of bisect. Or you could say bisector. You could say angle bisector, definition of angle bisector. And then finally, I have to put together what I've got so far. And I have angle 3 is congruent to angle 1. Angle 2 is also congruent to angle 1. Anytime two things are congruent to the same thing, they are congruent to each other by transitive property. All right, don't go on for number 4 until you have tried it on your own. Okay, number 4. Step 1, AB is 9, the length of AB is 9, and the length of BC is 7. That comes from right up here in the given information, so that's given. Step 2, AB plus BC, the length of AB plus the length of BC equals the length of AC. Honestly, this is given also, but it didn't need to be. We should already know that AB plus BC will give me AC. That's, I'm going to say given, but that's the segment addition postulate. Part plus part equals whole. So they didn't have to give that to me, but they did. Now, looking from step 2 to step 3, it looks like I put a 9 in place of the AB because AB is 9. And I put a 7 in place of the BC because BC is 7. Putting one thing in place of another in an equation is substitution. And then here's that simplify. We're just putting together the 9 and the 7. We're not doing anything to both sides. So even though we're adding, we would never call this addition property of equality because we're not adding anything to both sides. We're just putting them together right as they are. And that's simplify. Or combine like terms. Always go with what your teacher wants you to say. I'm fine with either of those. Number 5, don't let me show you how to do it unless you've tried it yourself. On all of these, you should be able to fill in at least one blank on your own. Even if you're like, I don't understand proofs at all, you should be able to find what's given and put that information, put given in that spot. So NA is congruent to AM. I'm going to mark that. NA is congruent to AM. All right, found it down here. And M is the midpoint of AB. M is the midpoint of AB. All of that was given. And remember, when we use words like midpoint, I'm pretty sure that the next thing we're going to do is talk about what it means for this to be the midpoint. If that's the midpoint, then these two parts on either side of it have to be congruent. So AM has to be congruent to BMB, and that's exactly what this says. If M is the midpoint of AB, then AM is congruent to MB. That's the definition of midpoint. Next we have NA is congruent to MB. Well, here's MB, and NA is back up here. So NA up here says it's congruent to AM. MB also says it's congruent to AM. So we have two things that are congruent to the same thing. That's transitive property. Now, let me just tell you something real quick. People tend to get transitive and substitution mixed up because they're pretty similar. Here's one of the ways you know different. One of the differences for sure. Substitution property, there is no substitution property for congruence. It's only for equality. So if you're dealing with congruence, you can't use substitution. Okay? So you have to use transitive, assuming transitive applies. There's no reason to get confused and think, well, could this be transitive or substitution if you have congruence? It could only be transitive. Next. Moving right along, given that H is the midpoint of GI, okay, I'm going to go over here and mark that. H is the midpoint of GI. That means that those two are congruent. Notice that I'm going to say that on the second step. And JH is congruent to HI. That was all given. And we just said that our second step is using that word midpoint to point out, well, if this is the midpoint, then either side is congruent. So that's definition of midpoint. And then once again, we are taking two statements that are both saying something's congruent to the same thing. Here, GH is congruent to high, and here, JH is congruent to high. So if they're both congruent to high, they have to be congruent to each other. That is transitive property. Okay, so I think that's probably enough for today for you. Tomorrow we're going to get into doing proofs with parallel lines, things like alternate interior angle theorem, alternate exterior angle theorem. We're going to use some of those. So I hope this has helped you get a little bit less, I don't know, I don't want to use the word terrified, but some people are terrified of proofs. I hope you are starting to see that they are not as completely a different language as they seem like they might be at first. Proofs are actually very doable, especially if we start small, which we have. So, thanks for coming. Hope you enjoyed it, and I'll see you next time. Bye-bye.